Hi, my name's Ken Crooks. I'm the sales engineer here at Phoenix Controls. I support our sales channel and our customers. When customers come to visit the factory, one of the important things we do is take them out here and show them the red valve demo. It's an operational valve with a clear plexiglass cover on it, so you can witness firsthand the mechanical pressure independence characteristic of the Phoenix valve. Each air station is equipped with a computer and a screen that shows you -5 to +5% accuracy. That's the blue bar at the bottom. There's also a readout of CFM. So in lab-like conditions, NIST-traceable devices, we do measure flow at Phoenix Controls, but here at Phoenix Controls, not in our devices in the field. So what we'll do with a red valve is we'll vary pressure. We speed up our fan. We start off though with just 3/10 of an inch pressure drop. And with just that small amount of pressure, the cone is still able to do its job to maintain ±5%. Once we see that, we then ramp up the fan more, go to an inch total pressure. And we'll vary that pressure drop across the valve, showing that cone moving further inside the venturi, still maintaining constant flow through the device, ±5%. And then we'll ramp it all the way up to 3 inches pressure drop, our maximum on the Phoenix valve, and the cone's further seated into the venturi, maintaining ±5% of set point at all times. So when a variable air volume terminal unit is connected to our air station, or VAV box as it's commonly called, they measure flow. They're not mechanically pressure independent like the Phoenix valve. Any change in pressure drop is then a change in flow. And it has to measure that change. The controller then has to move the actuator. That takes time. You could lose room pressurization. You could lose fume hood containment. There's also inaccuracy with that. When we're done with the pressure drop tests, we then take the red valve demo, and with a flexible duct on the inlet side of it, we'll move it all around and simulate some of the real-world conditions we see. Buildings as they're built today, there's just not a lot of room for straight duct runs. And so even with an elbow directly feeding into the valve and directly out of the valve, there's no impact on the valve's performance. With a VAV box, per ASHRAE design guidelines, they need 10 duct diameters of straight duct, 7.5 on the inlet side and 3 on the outlet side, to get as accurate as they can possibly be. That's just not really obtainable in the built environment today. So another important test we do here during the red valve demo is inject lab tissues into the duct stream and watch them get stuck or flow straight through the Phoenix valve, and how it has no impact on the accuracy of the Phoenix valve. The mechanical pressure independence, the cone spring assembly, not affected by any lab tissues being stuck inside. With a VAV box, it takes just one tissue draped across that flow measurement device, and all bets are off. We've seen 30% loss of accuracy from just one tissue. The red valve demonstration shows our customers really what they need with a terminal unit, the safety and savings that come from mechanical pressure independence.